So today's video is about the number properties. Today's video is going to be a little different. Usually, I have the examples and you have to pretty much fill in all of the notes for the examples, but you're going to see that how I want you to fill in some of the notes will be a little bit different today. So let's start with what are number properties. They are a set of number rules that help you solve math problems. And why are number properties important? Well, it's what rules do. They help you understand what you're allowed and not allowed to do in a math problem. So it's basically, rules are what you can and can't do. So number properties are rules that tell you what you can and can't do in a math problem. So let's start with the first property, and I know this should be familiar. It's the commutative property, which means that you can change the order of an addition or a multiplication problem and still get the same answer. So we have a picture model here. If I had 2 apples and I added 3 apples, it would give me a total of 5 apples. Well, if I switched the order and I took 3 apples and I added that to 2 apples, it would still give me 5 apples. So even though I switched the order, I still ended up with 5 apples in the end. Then here I have 2 oranges times 4 oranges, and that would give me 8. Or I can do 4 oranges times 2 oranges, and it would still give me 8. So here are some examples down here where I switched the order of the numbers, but I still got the same answer. So I have 8 plus 7, 7 plus 8 will both give me 15. 110 plus 6, or 6 plus 110 will still give me 116. 9 times 3, or 3 times 9 will still give me 27. And even when we look at variables, A times B and B times A will still give me AB. Some non-examples would be basically subtraction and division, because if you switch the order of a subtraction and a division problem, you won't get the same answer. So if I do 12 minus 5, that will give me 7, but if I do 5 minus 12, that will not give me 7. That's actually going to give me a negative number, because I have 5 and I'm taking more than 5 away. Then I have 36 divided by 4, and that gives me 9. But if I switch the order and I do 4 divided by 36, that's actually going to give me a decimal. So another non-example, 9 minus 3 would give me 6, but 3 minus 9 won't give me 6. And 15 divided by 3 will give me 5, but 3 divided by 15 won't. So a non-example of the commutative property is subtraction and division. So it doesn't work with subtraction and division. So what I want you to do now is pause the video and then give another example of your own. So I left you 2 lines. I want you to give me an addition and a multiplication example of the commutative property. So go ahead and pause the video. The next property is the associative property. And the definition is you can change the order of the parentheses in an addition or multiplication problem and still get the same answer. So right now I have our symbol, our cougar. So I have 2 cougars plus 3 cougars in parentheses plus 1 cougar. So first I'll do what's in parentheses, and that will give me 3 plus 2, which is 5. And then I'll add 1 more, and that gives me 6. Then here, I switched the parentheses. So instead of it being around the first 2 sets of cougars, I put it around the second 2 sets. So now I have 2 cougars plus parentheses 3 plus 1. Well, again, I'll still do what's in parentheses. 3 plus 1 gives me 4, and 4 plus 2 still gives me 6. Same here. If I do it with multiplication, I have 4 houses times 2 houses in parentheses times 3. Well, 4 times 2 is 8, and then if I multiply that by 3, I get 24. Then down here, I didn't change the order of the numbers of the order of the houses, groups of houses, but I did change the parentheses. Instead of it being on the first 2 numbers, I put it on the second 2. I'll still follow order of operations, so I'll do 2 times 3 this time in parentheses, which gives me 6, and then I'll multiply that times 4, which still gives me 24. So if you change the parentheses, that means the order of the numbers stayed the same, but you move the parentheses. If it's addition and multiplication, it'll still give you the same answer. So here are some examples down here. I tried it with 3 times 6 times 2. I still got 36 both times. Notice the 3, the 6, and the 2, the order didn't change. But look, the parentheses were first around the first 2 numbers. Now it's around the second 2 numbers. And I still got 36 both times. Then in my next example, I still have the same order. It's still 42 plus 5 plus 20 each time. The only difference is first I had the parentheses around the first 2 numbers, then I had the parentheses around the second 2 numbers, and it still gives me 67. So regardless of where you put the parentheses. If it's addition and subtraction, it'll still give you the same answer. Non-examples, again, would be subtraction, division. If you have subtraction and division and you change the parentheses, it will change your answer. So let's look at this first one. If I do 26 minus 10 minus 8, first I have to do is in parentheses. I have to do 26 minus 10, and that gives me 16. And then 16 minus 8 equals 8. Well, if I keep the order the same and change the parentheses, 10 minus 8 gives me 2, and then 26 minus 2 actually gives me 24. So they are not equal. Same with division. If I do 48 divided by 8 divided by 4, I'll start by doing 8 divided by 4, which gives me 4, and then 48 divided by 4 gives me 12. Then if I change the parentheses and I do 48 divided by 8 first, and that gives me 6, and then I do 6 divided by 4, that actually gives me 1.5 or 1 5/10. So again, they're not equal, so it does not work with subtraction and division. Again, pause the video and give me 2 examples of your own, one with multiplication and one with addition. The next property is the zero property. The zero property of addition states that you can add any number to 0 and you'll get the same answer. And the zero property of multiplication states that if you multiply any number with 0, the answer will actually be 0. So I have 5 boys and I add 0 and it still gives me 5 boys in the end. And then here I have 6 girls and I multiply it by 0 and it gives me 0. So you know anything times 0 is 0. And if you add anything to 0, your number stays the same. So here I have some examples with multiplication and division. And you can kind of look over these and you can see if I multiply by 0, I get 0. And if I add anything to 0, my number stays the same. Some non-examples, the zero property only works with 0. So if I multiply or add by any other number, it will change the number. So if I do 38 times 2, it'll give me 76, and 45 plus 3 gives me 48. So it only works with 0. So now pause the video again and give me one example of the zero property on your own. Okay, our next property is called the identity property. The identity property means that if you add or subtract 0 from any number, your answer will be the same number. And if you multiply or divide any number by 1, your answer will be the same number. So I have my examples up here. And so I have 2 necklaces minus 0, and I still end up with 2 necklaces. Then I have 3 cubes plus 0 cubes, and I still end up with 3 cubes. I have 5 tigers times 1, and I still get 5 tigers. And then I have 4 carnations divided by 1, and I still end up with 4 carnations. So some examples would be 35 times 1, I get 35. If I do 27,502, subtract 0, I still have 27,502. So the identity property means that basically the number doesn't change. That whether you're subtracting or adding 0 or multiplying and dividing by 1, the number is going to stay the same. That's basically what the identity property is. Some non-examples would be if you add by anything other than 0, subtract by anything other than 0, it's going to change your number. If you multiply or divide by anything other than 1, it's going to change your number. So now what I want you to do is pause the video again and give another example of your own. So now, teach to the tiger. Teach me one thing that you learned in the video, and when you're doing your teach to the tiger, I want you to at least talk about one of the properties in detail.